Hello friends, today I am going to discuss some important MCQ on thermodynamics. I have already explained 40 MCQs, 40 to 50 MCQs in previous lectures. Today I am also going to discuss some important MCQs of thermodynamics for Mahagenco exam 2023 for assistant engineer and junior engineer, myself Dhoni LS. Now we will move towards the question number 51 of this lecture. First question of this lecture is question number 51. What is the question number 51, friends? A gas which obeys the kinetic theory perfectly is known as. A gas which obeys kinetic theory perfectly is known as. Option number A is given. What is option number A? Monoatomic gas. Then option number B is diatomic gas. Option number C is real gas. And option number D is pure gas. And option number E is perfect gas. So what will be the answer? The answer is perfect gas. Why answer is perfect gas, friend? First of all, we must have to know what is the perfect gas. Perfect gas is the one which obeys all gas laws, friend, and the kinetic theory of gases, because it is hypothetical gas. Perfect gas is a hypothetical gas due to this which obeys the all gas laws and kinetic theory of gases. Then option number A, what is option number A? Monoatomic gas. This is not the answer, because why? What is the monoatomic gas, friend? See, what is the monoatomic gas? Monoatomic gas means monoatomic gas is a gaseous substance composed of molecules that each contain one atom. Monoatomic gas is a what is monoatomic gas? Is a gaseous substance composed of molecules that each contain one atom. Each contain one atom. One atom. That contain one atom. That contain the one atom each. So what is the example of monoatomic gas? Example of monoatomic gas is helium. Helium is one of the example of monoatomic gas. So this gas consists of one molecule, and due to this is a non-hypothetical gas which occupies some space, and due to this is not the option, and this monoatomic gas does not obey the kinetic theory perfectly. Similarly, diatomic means two atom. What is the example of diatomic gas? Is that contains the two atoms. An example is H2. What is the example of diatomic gas? H2, O2. These are the examples of diatomic gas, and it consists of two molecules. It consists of two atoms of the two atoms in the molecules, and due to this which occupies the space, and this is also non-hypothetical gas, and which does not obey the kinetic theory perfectly. So this is not option. This is also not correct option. Real gas is also hypothetical gas. Due to this is also not the option. So option number E is the correct answer, perfect gas. So we will move towards the question number 52. What is the question number 52? Just a minute, friend. I will erase it. Okay. Now we will move towards the question number 51. Sorry, 52. Work done in pre-expansion process is 0. So why the work done? What is the question, friend? Question number 52 is work done in pre-expansion process is 0, or minimum, or maximum, or positive, or negative. These are the options. So option number A is correct, 0. So in pre-expansion, no external pressure is C, friend. In pre-expansion process, what is the pre-expansion process? Let us suppose this is a chamber. which is completely insulated from the outside region. Completely insulated from the outside region, and there is one partition in between this chamber. Let us suppose gas is inserted in this chamber. After some time, when we remove this partition, this gas will expand freely inside this chamber. This is known as a free expansion. So free expansion means no external pressure is applied to the gas. In absence of external pressure, gas expands by its own, and thus due to zero external pressure, what is the pressure value here? Zero. There is no external pressure. Zero external pressure, and heat transfer or work done is zero. And due to this, and heat transfer also here zero, because it's completely insulated from the surrounding. Now, what is the formula of work done? Work done is equal to P into dV. What is the formula of work done? P into dV, which change in volume. So the value of P is here 0, and due to this, work done is also 0. Due to this, option number A is correct answer of the given question. Now we will move towards the question number 53 of this lecture. Now, what is the question number 53, friends? See. Which of the following is not property of the system? C. Option number A is a temperature. Option number A is temperature. Is it property? Is it property, friend? Yes, temperature is property, because temperature is an intensive property which is independent upon the mass. Intensive property. Pressure is also property. Intensive property, which is independent upon the mass. Pressure is also one of the property, intensive property. The specific volume is also property, but heat is not a property. Heat is a path function. Heat is not a property of the system because it cannot be used to describe the physical condition of the system, and it is a path function. It is a path function. Due to this, heat is a correct option of question number 53, because what is the question? Our question is which of the following is not property. So heat is a not property. It is not property. So we will go towards the question number 54. What is the question number 54, friend? In polytropic process, equation PV raised to n is equal to constant. If n is equal to 0, the process term as. See, friend, this is very important question. Such type of questions may be asked in competitive examination. PV raised to n. PV raised to n is equal to 0. Now put the value of n is equal to 0. What happened? PV raised to 0 is equal to 0. And what is the value of V raised to 0? A raised to 0 is equal to 1. A raised to 0 or V raised to 0 is equal to 1. Therefore, sorry, PV raised this is not 0, sir, friend. Sorry, friend. This is not 0. This is not 0. This is constant C. Just a minute. This is not 0. This is not 0. So this is wrong. 1 minute. So this is C. PV raised to n is equal to constant. So friend, if we put the value of n is equal to 0, then what happened? PV raised to 0 is equal to constant C, and the value of V raised to 0 is equal to 1, and due to this 1 multiplied by P is equal to P, and this is pressure is equal to constant. This is constant pressure process. This is also known as isobaric process. This constant pressure is also known as a isobaric process. So option number B is correct answer of this question. Question number 54. Now we will move towards the question number 55. What is the question number 55? In polytropic process equation, PV raised to n is equal to constant. If n is infinitely large, the process is termed as. See friend, this is also same question as that of the question number 54. What is the relation? See, PV raised to n is equal to constant. PV raised to n is equal to constant. This is the relation. Now put the value of PV raised to infinite is equal to constant. And what happened? The P, that is V, is equal to constant. That is V is equal to constant. So this process is known as a constant volume process. This process is known as a constant volume process because V is infinite. V raised to infinite is equal to PV raised to infinite is equal to constant, and to this V is equal to constant. This is known as a isochoric process. This process is also known as isochoric process. So this is the answer. Question number A is the answer of the question number 55. Now we will move towards the question number 56. What is the question number 56, friend? The processes or system that do not involve heat are called as. Options are given here. Option number is isothermal process, then equilibrium process, thermal process, and steady process, and adiabatic process. Option number E is correct. Why option number E is correct, friends? When the thermodynamic system undergo change in such a way that no exchange of heat take place between system and surrounding, the process is known as adiabatic process. Means adiabatic process is the process in which delta Q, change in heat, is equal to 0. Delta Q is equal to 0. Delta Q is equal to 0 means there is no exchange. There is no exchange of heat between system and surrounding, and this is known as adiabatic process. The question number, what is the question number 56? The process or system that do not involve heat interaction is called as adiabatic process. So question answer now, option number E is correct answer of the given question. See friend, now we will move towards the question number 57 of the today's lecture. Just a minute, I have to erase this part. Okay. Question number 57. In a reversible adiabatic process, the ratio T1 by T2 is equal to. So we must have to know what is the reversible adiabatic process, and then we can solve this equation. So this is the relation for adiabatic process. What is the relation? The ideal gas. What is the ideal gas equation, friend? PV is equal to MRT or nRT. MRT. This is the ideal gas equation. Then PV raised to gamma is equal to constant. This is the relation for adiabatic process. So V1 raised to gamma is equal to constant. This is the equation number 1. Similarly, P2 raised to gamma is equal to constant. This is equation number 2. Now compare these two values, because right hand side of the equation, both equations are same. So V1 raised to gamma is equal to V2 raised to gamma. Then we will put the value of V. What is the value of V? V is equal to m r t divided by P. When we will put this value in this relation, then we will get the relation P1 m r. This is the mr is nothing but a constant. T1 divided by P1 raised to gamma. Similarly, P2 m r T2 divided by P2 raised to gamma. And simplify this equation, we will get P1 raised to 1 minus gamma into T1 raised to gamma is equal to P2 raised to 1 minus gamma into T2 raised to gamma. See, what is the relation? What are the options? Options are in the terms of pressure and volume. So we can solve this relation T1 by T2. We have to find out the T1 by T2. Then what happens when we collect the same terms to the right hand side and left hand side? Then we will get this raised to gamma and P2 raised to 1 minus gamma divided by P1 raised to 1 minus gamma, or this bracket raised to 1 minus gamma. Then if we write in terms of, let us suppose we write in terms of T1 by T2 only. T1 by T2. T1 by T2. Then what happened? This relation become P1 by P2 raised to P1 by P2 raised to gamma minus 1 divided by gamma. So what is the option? Option number A is the correct answer of this question. Option number A is correct answer of this question. Now we will move towards the question number 58, friend. So you can simplify by using this relation. You will get the answer of this question. Okay. Now we will move towards the question number 58. What is the question number 58, friend? Just a minute, I have to hear. Okay. Question number 58. In isothermal process. What is the isothermal process, friend? The isothermal process is a process in which temperature is constant. Is it correct? Isothermal process is a process in which temperature is constant. Due to temperature is constant, this process is known as isothermal process. T1 is equal to T2. See, friend. We have given options here. Option number A, temperature increases gradually. This is not the correct regarding isothermal process. Volume remains constant. This is also not correct regarding the isothermal process because volume is constant in isochoric process. Option number C is pressure remains constant. This is also not relation because this is regarding isobaric process. Enthalpy change is maximum. This is also not correct. Change in internal energy is 0. This is correct because when we see the relation between internal energy U2 minus U1 is equal to M into specific heat at constant volume, which is known as a CV, into T2 minus T1, T2 minus T1. When T1 and T2 same for isothermal process, this T2 minus T1 become 0. This value become 0 and multiply. If we multiply any term by using 0, then it will become the 0, and internal energy or change in internal energy delta U will become 0. So due to this, option number E is correct answer of this question. Option number E. In isothermal process, change in internal energy is 0. Change in internal energy is 0. Now we will move towards the question number 59 of the today's lecture. What is the question number 59, friends? During throttling process, I have already explained this throttling process in my previous video. This process is also known as isenthalpy process. Why this process is known as isenthalpy process, friend? Due to this, enthalpy of the system in this process, enthalpy of the system remains same. Means H1 is equal to H2. H1 is equal to H2. H1 means enthalpy of the initial state, and enthalpy of the final state remains same. H1 is equal to H2. This process is known as throttling process. This process is known as throttling process. So options are given here. Internal energy does not change. This is not the correct option. Pressure does not change. This is not option. Entropy does not change. This is not entropy does not change. This is also known as isentropic process. This is known as isobaric process. And volume change is negligible. This is not the answer. So D, option number D is the correct answer of this question. Enthalpy does not change. So friend, this is the question number 59. During throttling process, enthalpy does not change. Now we will move towards the question number 60, which is the last question of this session. What is the question number 60, friends? See, when gas is to be stored, the type of compression that would be ideal is it isothermal, B adiabatic, C volumetric, D constant volume, or E none of the above, which is the correct option here. So for isothermal compression, see friend, for isothermal compression, work of compression is minimum. Work of compression is minimum. Work of compression is, for isothermal process, work of compression is minimum. This value is minimum. Work of compression minimum. Hence, isothermal compression is ideal compression process. Hence, isothermal compression is an ideal compression process. Due to minimum work input required to the isothermal compression, it is ideal process for the compression. And due to this, option number A is correct answer of this question. When gas is to be stored, the type of compression that would be ideal is isothermal. So option number A is correct answer of the question number 60. So this is the last question of our session. I have taken these questions from the reference book. I have already told in previous lecture, Mechanical Engineering book by R.K. Rajput. Thank you, students. Today we will stop here. Keep watching my video and subscribe the channel. Thank you, friends.